Okay, so let's get restarted. Okay, we just compiled our shaders, and well, we now need to draw that triangle. We have everything we need to draw the triangle, but still, you'll see that there's some configurations to be done to actually send this triangle to the GPU, because it's important to keep in mind here that we are working in these two different environments. And when you write this code here on line 41, we are defining a variable in memory, and this is main memory, right, of the computer. We have to send these vertices to the GPU. So that's what you're going to do right now. And this concept, it's also fairly important. It's a main source of confusion for a lot of people. So pay attention, and also like really read this carefully in the book and practice this as much as possible. And part of this course is to practice this, but this idea of creating buffers and manipulating buffers in the GPU is kind of equivalent to when you are learning C and you have to do like kind of dynamic memory allocation. This is like my claim. I think for me, when I learned this, was kind of complicated to understand, and it's kind of, and is this, you have to kind of have a mental model of the memory of the GPU in your head. So that's why I think it's similar to memory, like dynamic memory allocation, but it's not that complicated. What I want to point out here is that this is a new type of thing that it might not be, you might not have seen this in other languages. So just like this is an important concept. So what we're gonna do is we're going to send, let me type this here, like we need to send our vertices, or in other words, our triangle, in this case, to the GPU. Right now, it is only in the main memory. So how do you do that? We have to create a buffer for that. So we're going to say let vertex buffer equals to GL create buffer. This is a function from GL that creates a buffer for us on the GPU. And as usual, I'm going to say if not vertex buffer, then print a message can't create buffer, and return -1. So second step is to bind this buffer. And what does it mean to bind the buffer? Let me type the line first, and then I'll discuss what it does. So this is bind buffer. And here you have a target and a buffer as arguments. So the target here is a GL. This is a macro variable, array buffer. And all these different variables and macros, maybe not all, but most of them are discussed in the book, because you have different options when you are binding these buffers. But basically here, what we want to do is we are saying that we want to make this vertex buffer. We're going to map this vertex buffer here, which is in memory, in the CPU memory, to be the array buffer in the GPU. So the GPU has many buffers, and one of them is this array buffer. And this is where we're going to read our vertices from, or basically we're actually going to load our vertices from the main memory to the GPU memory using this array buffer. And for most of the assignments, we won't change this, but there is other buffers you could load variables to, or you could variables, no, but arrays to them. So let's make a comment here saying we have to bind we have to bind this new buffer to the A position attribute in the vertex shader. And we don't, in this line first here, just say set the array buffer to be the vertex buffer, but the next line, we're gonna actually retrieve, that's an interesting part. We're gonna retrieve this variable A position from the shader to the main memory. So you wanna copy, have kind of like a interface between the CPU and the GPU. So what we're gonna do is we're gonna find the address of this variable in the GPU because we need to set it, right? So then in order to do that, we're gonna use the function gl.get attribute location. And here we have two attributes. One is the program, and the second one is the name of the variable. What is the program? So basically the program is the compiled shader. And the compiled shader, it is stored in this gl.program variable. So here, whenever you run this init shaders part, you get the compiled shaders stored here. So what we want to do is we want to get from the shader the variable, and now this is a string, we're going to get the variable A position. And this has to match exactly the variable you wanna get. So let me copy this here and paste just to make sure like I'm actually getting the right thing. And this returns, now we have the address. So this A position here doesn't have to be the same name, but I like keeping the same name because this is a mirror. Let's say it's a mirrored version of this variable in the GPU, in the CPU. So now we have actually the address of this variable in the shader so we can manipulate it. So here I want to say we retrieve the A position, retrieve the address, let's say, of A position variable from the shader. And now we're going to set that variable. We're going to change it, or we're going to pretty much load our triangle, because that's the end goal, right? We want to say that our vertices, or we want to map our triangle array to this variable A position in the GPU. So to do that, we're going to have to write a few lines. And let me start with gl.vertex attribute pointer. And this might be the most confusing line for students based on my experience. Like for this assignment, it's going to be pretty simple. But moving forward with more complex geometries, especially on 3D worlds and all of that, this can get kind of confusing. And because also it has many attributes, but let's try to kind of break it down. So the first argument, first of all, what this function does is it's going to define how this array here is going to be interpreted as a collection of vertices. We are assuming here as programmers that this is X and this is Y, and this is X and Y, or let's say X1, Y1, X2, Y2, and X3, Y3, right? We are assuming this, but for the computer, this is just a list of 6 numbers. So especially for WebGL, it doesn't know that we are trying to make this be X and Y, and this also be X and Y, be X and Y. So we have to specify that. And especially if you had 3 coordinates, we had to specify, now I want 3 coordinates, right? So this line here is to specify that. So I want to specify basically how to read this triangle array. Okay, so the first attribute is the variable that I want to set. In this case, a position, and this is coming from here, right? So we're gonna set this a position variable in the shader, but now we have the address here. Size. What is size? Size is the size of of this variable as a vector. So let's go to the shader and see. This is a vector 2, right? So here what you want is the size to be 2. Now we're starting to tell to the shader that, well, this variable a position is going to be read from triangle. We didn't say that yet specifically, but we were telling it that each vertex has size 2. So read this thing in pairs. Like, that's why this 2 is coming from. Now we have to specify the type of these elements. And we are saying all of them are going to be gl.float. Okay, so look at this. These are all floats. Okay, so far, I think so good. Nothing really challenging. The fourth variable is, do we want the GPU to normalize these numbers? We're gonna say false. No, I don't want that. I just want to read as they are. Don't normalize my vertices. Okay. And these two last arguments are perhaps the most confusing things, but because we are starting there and there's a lot of information here, and this assignment, it turns out they're going to be 0 and 0. But later we're going to change this. And let me just quickly say what they are. But we're going to explore these arguments later. So here, what we want to say is you can use these numbers to configure more complex behaviors in how to read this triangle. And this is going to be useful sometimes because we will learn that you can store not only vertices in this array, but you could also store, let's say, other information. Like you could store colors, or you could store, let's say, we're going to see this when you're dealing with lighting. We're going to need the normals of each vertex also together with the vertex information. So for each X and Y here, we're going to have let's say, information like RGB, and then maybe N, X, N, Y, and N, Z, which is our normal X, normal Y, normal Z. I'm talking about normal vectors here. And so for each of these, we would have all this information. So now each vertex would be packed with a bunch of information. So I would have to tell my shader, well, which part is the X, Y, which part is color, which part is normal. So to specify that, I would have to play with these numbers here, which are pretty much kind of like shifts. Like, for example, in this case, I would say each vertex has 1, 2, 3, 4, 5, 6, 7, 8 elements. And here I would probably put 8 times the size of a float. And so this can get a bit complicated. Right now, I just want to quickly introduce this. Because we are only dealing with X and Y coordinates, we're going to keep this 0, 0. Okay, I don't want to talk more about this because we're going to have a specific lab just for these two arguments here and playing with them and seeing the differences. But for now, let's just keep it simple, 0, 0, because we are only reading X and Y elements in this array. I hope that makes sense. We're going to stop for questions in a bit, but that's it for this line. This is right now just saying that we have pairs X and Y of vertices, and we have 3 pairs here. Because we said this is 2 and you have 6 numbers. If you have 6 by 2, we have 3 vertices. Okay. And finally, for enabling we have to enable the vertex attribute array. So here we're going to say, this is actually the function that enables all these changes. At least it kind of like commits like this, or change really perform or enables all these changes to happen. And this is important because we might have different, in memory, you might say in a complex application, you could have more than one buffer, and you could maybe switch between and enable different buffers in different times of the application. So it's good to have this function to enable and disable things as you need. In this case, you just have one buffer. So we will just run this once and that's it. Okay, so here we are retrieving, and let me type here. Here what we do. Here we are kind of like configuring the buffer, or the buffer to read the vertices correctly from the triangle, from the triangle array. And for this application, for this specific example, a triangle is made of x and y vertices, and that's why it is 2 here. Okay. So finally, we need to send our vertices to this buffer. We actually have to set this buffer with values. Pretty much what we have to do is say, okay, send triangle to the buffer. And here it's going to be GL buffer data. And we're going to say GL array buffer again. And here is our triangle variable. So now we are sending literally this array from the memory to the GPU. And we want, this last argument is how we want to draw this. Oops. We want to draw this as a static draw. I think there's two main different types of draw, dynamic and static. And let's not talk much about this because right now, but basically in GL, you're saying that these vertices somehow are going to change or not throughout the process of drawing, but let's not go too much deeper. There's already too much of information, too much of like attributes and stuff to remember. And this won't be very important for this assignment. And honestly, we might not even change this for this whole class. So let me just right now assume this is this value. Okay, and I think we are now ready to draw. And you know, like we have written all these lines and we still haven't seen any change in our code. Let's actually refresh the page and see if we made any problems, added any errors. And no, it seems it's still working good.